Welcome to this lecture on survey as part of Engineering Graphics, EGN 2123. If you need to reach me and you have any questions concerning this particular content, here's my cell phone. I may regret giving it out, but here it is. So what are our goals for this learning period? We want to understand how to correctly identify a survey using AutoCAD, learn how to display points, learn how to measure angles in two formats, and how to display line lengths. This is your typical survey that you're going to cover in survey class. We need to put it on paper, however. So the first thing we need to do is install some points. We're going to use the point style command, DDP type or PD mode, to set the point styles. We're going to use points or the point command. You can find this on the ribbon, or you can type in point. Also, you may or may not want to use the snap command or OSnap to place your points at certain. The first thing we need to do is set up the units of the project that gives us the proper working platform. Okay, so the command is units. It'll pull up this dialog box. We want to change, we can put engineering or we can add decimal feet. Also, the degrees will be in surveyor's units, or we can put it in degrees, minutes, and seconds. We'll be doing both in this exercise. Notice it gives us the expected output, and we need to change the units to feet. Okay. We can change the direction if we need to between north, south, east, and west. Just hit OK. Now that we've got the units, we can start with our points. We can get there, as mentioned previously, DDP type. Bring up the dialog box to change the point styles. There's several options here. Particularly, I'm going to use this option. You also change the point size, whether it's relative. I'm going to change it to 5% of the screen. After I set that point style, I can simply use the ribbon and pull down and select a point. Anywhere I click puts a point. This is going to be the starting basis of our survey. I can also type the word point and select those as well. By selecting the point and hitting properties, I can bring up the XY, or otherwise known as the northing and easting coordinates. I can change those if needed. For instance, maybe I want it to be 1300 easting, which is the X. I can also give it a Y coordinate, say 1400. I'll leave the Z as it is right now. So as it moves, I'll probably have to zoom out. I can zoom extents. I can also pan as needed. And my point is way off at the moment, but I can match coordinates with whatever the survey says. Now, for your particular survey exercise, you can put the northing and easting. You can match it to the plane coordinate system, or you can use an assumed location of, let's say, 10, 10 or 100 by 100. And next thing we're going to do is start installing some. From our base point that we established earlier, I'm going to select a line. Now, as soon as I hover over it, it snaps, and I could draw it anywhere that I wanted to draw it. However, I can enter through AutoCAD, I can enter the length at 50, gives it 50 feet in this case, with an angle of north, that's due north. So that's going to give me a line that is straight north, 50 units long. In particular, for surveying, this is one of the commands you're going to use. All right, our next length can be 102.745, which is typical of a survey, at an angle of north, 47 point, I don't know, let's make it 238. And we have to select either east or west, and we'll select the east. So it has given us the correct line using the azimuth and the length that we selected. Now I want to go back and change the units. Instead of surveyors, I'm going to put degrees, minutes, and seconds. I'm going to change the precision and give it some typical measurements. Hit OK. Again, if I hover and I can snap, I'm going to use line, and I can snap to the end of the line. Now when I enter the length, I'm going to use the same @ symbol. We'll give this one a length of 108.345. Angle, now we'll give it a degrees, minutes, and seconds. Now for the degree, the symbol is D. So in this case, it's 176 degrees, 123 minutes. And I'll need to give it the seconds, 34.45 seconds. And I'm just making this stuff up. So now it has installed the next length at the correct azimuth with the correct length. I'm just going to finish this out for the sake of this exercise. Obviously, you would have different lengths and coordinates. Okay, after I've installed the complete transit, I'm going to install points on each node. Notice that it snaps to the nodes. I need to install my angles. Although I entered them previously, that does not tell the user anything about this particular, doesn't tell the length, nor does it tell the particular angle that this run was installed at. So I can change, go to the Dimension Style Manager, Dim Style, and I can work with the classic head, change many of the properties of it. What I am most worried about is the size of the text. I want it to be readable, and I want to change the angle measurements. Okay, so I have linear dimensions, and I'm going to change this in degrees, minutes, and seconds. In order to make a angle dimension, I can use the ribbon, or I can type dim angle. In this case, you just select each one of the items you're going to measure between, and it gives you an angle. Notice it's only in 133 degrees. The precision is not set correctly, and I need to fix that. 133 degrees does not give us much precision at all. So I'm going to go back to dim style. I'm going to modify the existing style, and I'm going to change the precision to something more realistic. Let's hit OK, and it's going to change the enclosed, and it's going to change it into degrees, minutes, and seconds, which is typical of what most surveys would look like. Okay, I'm just going to repeat the same thing. Angular dimension. And one thing you notice about AutoCAD is it doesn't like to go outside of 180 degrees. In this case, 133. I'm going to also dimension the acute side of it. Same for this angle. Again, angular dimension. I'm going to leave these up here for a little bit. Notice that they never go past 180 degrees, which can be problematic because our angles are can be and often are greater than 180 degrees. Let's finish this last angle out. Do the acute side of it, which is roughly 60 degrees. Now, I again mentioned that there was a problem with AutoCAD measuring past 180 degrees. Unfortunately, it's a very easy way to work around. I'm going to delete this, and I want to measure this angle that's much greater than 180 degrees. So the way I do this is you can go from the ribbon, annotate as the same thing, angular dimension. Now at the bottom, notice it gives me circle, line, or specify vertex. I'm just going to hit enter to specify the vortex. Now I need to mark the end of each line. And when I do that, it'll allow me to measure the angle greater than 180 degrees. In this case, it's 313 degrees and some odd minutes. Okay. I can also do the command, which is dimension angular, D-I-M-A-N-G. Again, hit enter for the vertex. Select each end of the line, and it will give me the obtuse angle. Again, select dimension angular, hit enter for specify vertex. Mark each end of the line, that the two lines that we're measuring. It will automatically give us the correct angle. That is our angles. And we also need the line length to tell our readers what the particular line. Now we can select the line, we could do properties, and then type the length in there. We might make a mistake. It might not be the correct length. We might transpose some digits. So there's obviously a better way to do it. We could use a linear dimension, although you can see what that's going to do. That's not particularly correct. But again, we want to measure this line here. There is a fairly easy way to have AutoCAD measure it. Again, we don't want to use the properties, although we can get the length off the line and then write it down on a piece of paper and transpose it over. That can be problematic though. So we have the tool that allow us to align a linear dimension. In this case, it's 134.2204. We have some issues with it because there's no units. Also, we have witness lines and leaders that confuse the situation tremendously. So I'm going to change the dimension style. Now I'm going to add a new one that's different than the angles. So I'm going to call this line. Okay, start with the standard. Continue. Now I don't want these leaders and the witnesses to appear, so I'm going to turn off the ends. Also, notice they're still there, so I'm going to turn off the dimension lines and the witness lines. Just by clicking those both off, it takes all of that, and the text still doesn't appear like I want it to. I'm going to change the size of the text, and I'm also going to make it angle with the line. So as soon as I hit this radio button, it will change the length. So now when I hit the dimension, it gives me the length of the line without all the witnesses on it, witness lines on it. Same here, 50 units. Again here, 50 unit or 102.6825. Again, just hitting the angular dimension. Or I'm sorry, a line dimension. I've been called angular. It's a line dimension. And the last one. There are all of our dimensions with our angles for our survey. Again, we don't know what particular units. It could be 102 meters, could be 102 feet, could be 102 inches. So we definitely need to define this. So go back to dim style and our line and modify. We're going to add a prefix to it. You can either add a prefix or a suffix. So we want to add the suffix. We want the word feet in there. So as soon as we do, it adds the word feet. Notice I put a space in there, so it's going to give it a space between the number and the feet. And that is our survey with the angles and the proper dimensions. So if you do have any questions about this, please reach out to me. I'll be glad to answer any questions you have. If not, hopefully you do well on your survey deliverable, and it's on a title block and has all of the correct things that a handout or a deliverable would have. Thank you again.